An induction motor works based on the principles of electromagnetic induction. Here's a simplified explanation of how an induction motor operates. Power supply. An AC power supply is connected to the stator winding of the induction motor. The stator winding is made up of multiple coils arranged in a specific pattern. Induction motor basics. User. Induction motor operating system. An induction motor does not have an operating system in the traditional sense like a computer or electronic device. It is a type of AC, alternating current, electric motor that operates based on electromagnetic induction principles. When an AC power supply is connected to an induction motor, the rotating magnetic field produced by the power supply induces currents in the rotor, the rotating part of the motor. These induced currents create a magnetic field in the rotor, which interacts with the rotating magnetic field from the stator, the stationary part of the motor. The interaction between the stator and rotor magnetic fields generates a torque that causes the rotor to rotate. This rotation allows the induction motor to convert electrical energy into mechanical energy, making it a widely used device for various applications such as pumps, fans, compressors, and industrial machinery. While there is no operating system involved, induction motors may incorporate control systems for regulating their speed or torque. These control systems can use various methods such as variable frequency drives, VFDs, or motor starters to adjust the voltage, frequency, or current supplied to the motor, enabling speed control and other performance characteristics. So, in summary, an induction motor does not have an operating system, but it can be controlled by external control systems to regulate its operation. User. How to work induction motor. An induction motor works based on the principles of electromagnetic induction. Here's a simplified explanation of how an induction motor operates. Power supply. An AC power supply is connected to the stator winding of the induction motor. The stator winding is made up of multiple coils arranged in a specific pattern. Magnetic field generation. When the AC power supply is applied, it creates an alternating current that flows through the stator winding. This alternating current generates a rotating magnetic field in the stator. The rotating magnetic field is produced by the interaction of the currents in the different stator coils. Induced currents. The rotating magnetic field from the stator induces currents in the conductive bars or windings of the rotor, the rotating part of the motor. These induced currents flow through the rotor conductors and create a magnetic field in the rotor. Magnetic field interaction. The magnetic field generated by the rotor interacts with the rotating magnetic field from the stator. The interaction between the two magnetic fields produces a torque on the rotor. Rotor rotation. The torque produced causes the rotor to rotate. The rotation speed of the rotor depends on the frequency of the AC power supply and the number of poles in the motor. The numbers of poles refers to the number of magnetic poles created by the stator winding. Slip. In an induction motor, there is a phenomenon called slip. Slip refers to the difference in speed between the rotating magnetic field and the rotor. The rotor speed is always slightly lower than the speed of the rotating magnetic field, which creates the relative motion necessary for induction to occur. Mechanical output. As the rotor rotates, it drives the mechanical load connected to the motor shaft, such as a fan or a pump. The mechanical load consumes the mechanical power produced by the motor. It's important to note that this explanation provides a basic understanding of how an induction motor works. In reality, there are various factors and design considerations that affect the performance and efficiency of an induction motor, such as motor design, efficiency, power factor, and control methods.